Alright, for question 77, it says each time your heart beats, your blood pressure first increases and then decreases as the heart rests between beats. The maximum and minimum blood pressures are called the systolic and diastolic pressures, respectively. Your blood pressure reading is written as systolic over diastolic. A reading of 120/80 is considered normal. A certain person's blood pressure is modeled by the function P of t, pressure in terms of time, which is in, minutes, is 115 plus 25 sine of 160 pi t, where P of t is the pressure in millimeters of mercury at time t measured in minutes, and it says to find the period. Well, the period is equivalent to 2 pi divided by k. K in this case is 160 pi, so what we have is 1/80th. Okay, now the fact that this is in terms of minutes, the period means that one full cycle is completed in 1/80th of a minute. So in the next question it says find the number of heartbeats per minute. Well, this symbolizes one heartbeat happens in 1/80th of a minute. Okay, that means that 80 heartbeats are taking place in a minute. So find the number of heartbeats per minute. Part B then would have to be 80. Now it says to graph the function and to find the blood pressure reading. How does this compare to normal blood pressure? Alright, I'm going to go back here. Let's just say that you were on your calculator and this was 10. Maybe. This was 10. Let me change this first. This was negative 10. Okay. And this was 10. Change this back to negative 10 and this back to positive 10. Okay, can't see a thing. Now it says that a normal person is between 120, is a maximum of 120 over a minimum of 80. So we probably want to go somewhere like 150 and a minimum. Now we can see the minimum, but we can get a better idea here if I can get this to select, which doesn't seem to want to work, so we'll forget that. For what it looks like a straight line, and again that's because the frequency is so high, and our window is zoomed out so far. So what we need to do is we need to change our x values. In terms of the x, we can start here at time 0 and we can go 1/80th of a minute, because remember, time is in minutes in this case. And what we have here is we have that here, there we go. Let's just go to like 70. What we have is we have that one full cycle. Now that's only one because we're in 1/80th of a minute right now, but from here we can find the max and the min. It's a periodic function. These values are going to repeat. So what we have here, using our calculator, second calc, max, can't tell what that value was, I think it moved it on me. This value here, if we can take this value and slide it, which I can't do very well. The program's not behaving, but if you were to take a look here on your graphing calculator, change your window accordingly. Again, second calc, max and min, left bound, right bound, guess. What you're going to see is the maximum pressure is 140 over a minimum pressure of about 90. So how does that compare? It's high. Those levels are elevated. Might want to go see a doctor at that point. So that's how you complete question 77 from the homework. And again, remember this piece of information right here. This period, okay, is it's a given amount of time. In this case, minutes. So it's completing one full cycle in 1/80th of a minute. Therefore, the full cycles per minute then would be 80. And then from there, graph in terms of setting your window, your viewing rectangle. Again, just zooming out or zoom fit. It's really not going to give you necessarily a real accurate picture, or as clear as we can do here. Just take a look at max and min and set those values, and then from there set your x values according to your period or your frequency, however you want to look at it. And that's how you do question 77.